So again, digging into the Energy Independence and Security Act, this is actually the first paragraph out of Title 13. And what it is, when you talk about smart grid, is it's a set of performance objectives. So these are basically the 10 things that they said that we really need to do. By the time you get all of these incorporated and built, this will constitute what a smart grid is. And so what they've done then is they've left it up to industry to come back and say, and provide the methods that they're going to go through this. So you can see some of the things that they're talking about in here, the whole idea of smart appliances, the ability for customers to get more involved in terms of their energy control and their energy usage, energy storage and peak shaving. If you recall in those NEMA product sections, I mentioned that we have an energy storage group, that's what they focus on. The increase of digital controls. Now this is very interesting. If you take a look at the controls, some of the control systems that are out in the grid, here we are in the 21st century. We've got Twitter, we've got tweeting, we've got Facebook. We can get instantaneous information about just about anything at any point in time, you know, at our fingertips. And we as consumers expect that. Some control systems in the grid get updated on only 15-minute intervals. That's not a good way to run an electric grid. I mean, electrons are moving so much faster than that. The entire landscape of the underlying grid can change in terms of demand and the amount of power that's being generated, and the management systems are going to be missing, because they're only updated every quarter of an hour. It's just absurd. So one of the objectives that they established right off the top, and in fact number one on the list, was the whole idea of let's apply the computing power that we now have to the electric grid and let's improve that performance. So that was a very, very key decision. Dynamic optimization is another one of their objectives, and again it's that whole idea of second or sub-second control in terms of what's going on with the grid, so that the fewest amount of power is lost as we're going through the process of generation and consumption. Integration of distributed resources is another feature, and that's the whole idea of if I put solar panels on my house that I can actually feed down into the grid. This also drives a concept that's called microgrids, which is something we'll take a look at a little bit later on here, where you can have a community that's basically self-sufficient. They do their own power generation and consumption. They can manage it locally through the use of storage and other things. And the whole idea of getting away from single sources so that you have single points of failure in terms of power generation and power consumption. Demand response is a huge program, and actually that's one of the focuses of the National Institute of Standards and Technologies. We'll cover them in just a little bit here. But demand response is the whole idea of you've got a warm summer day in Washington, D.C., you've got a rising heat index. You know that at some point in time that the demand for power is going to peak, and it may exceed the ability of the amount of power that we can generate. That represents a problem. So what you have to be able to do is find some way to curb that peak through demand response so that you can turn off various things in building systems. You can cycle people's air conditioners on and off so that you don't actually exceed that peak and you don't end up with a brownout. And we've all been through brownouts in the summer. It's not fun to sit there and sweat. Smart metering is another thing that this has actually been really the first manifestation of smart grid. You'll find out that a lot of power companies have gone out there and installed literally millions and millions of meters. We have several manufacturers. One of our product sections actually focuses on smart meters, and they've reported orders well into the tens of millions. And the whole objective is that I think by 2035 that we will have 100% smart meters in the network. And the difference between the smart meter, the meter that's on the side of your building, and the difference between a smart meter and the meters that are on the side of your building today is that the smart meter actually has two-way communication and power flow. So again, if I have a set of solar panels on my roof, I can actually feed power back into the network and it'll come off my bill. At the same time, you know, the whole idea of passing dynamic pricing down to the appliances in my home, the smart appliances in my home, so that if we are having one of those hot summer days and they want to curb demand, they can send a signal down to my home and the appliances in my home will respond. You know, the toaster can shut itself off, the dryer can shut itself off, the air conditioner can cycle, so that we can actually save that power and respond properly to the demand. The whole idea of reducing market barriers. This is really to encourage innovation in the marketplace. That's one of the objectives. It actually shows up in a couple of different themes. We've got it coming up here in a slide from the Department of Energy as well. Yes, sir.
Paul, if they have questions, should they hold them to the end?
No, anytime. Ask questions anytime.
Well, I've got a question.
Yes, sir.
The emphasis here is on intelligence and communications. If this was a football game and I wanted to score a touchdown, I wouldn't give the ball to Albert Einstein. I give it to John Riggins. You need a certain robustness. You can intellectualize and communicate, but if you don't have the robustness of a grid that can actually carry out some of these things, it's all for naught.
You are exactly correct. You're a very good shill. What we've got, so this is what this was Congress's vision of what the energy landscape should look like. So now what you've got to do is, the next thing that happens is the federal agencies, to include the Department of Energy and the Department of Commerce through the National Institute of Standards and Technologies, they came back around and said, okay, well, their method of accomplishment, and actually that is one of the DOE objectives. So I'll get back to that in just a minute if it's not on the next slide. It's coming up very quickly, actually. So then you take that Energy Independence and Security Act that starts like this, and then you break it down. These are the responsibilities that states have, the National Institute of Standards and Technologies, the Federal Energy Regulatory Commission, and the Department of Energy. So this is basically by section of that Energy Independence and Security Act, who has what responsibilities and where they're shared. If they're dotted line, they're tied together. You have multiple agencies that are working on that. And of course, right here in the middle, under the whole idea of the interoperability framework, you've got me. You've got NEMA right there. So we were actually one of the very few non-governmental organizations that was named in this federal law. So we have that gives us a very good opportunity to be able to contribute to the smart grid effort because we're actually named to work on this whole idea of interoperability. I'm only 2 slides away from the answer to your question. So in terms of the affected offices within the Department of Energy, as you can see, they have a number of provisions from the previous slide that they're responsible for over there on the left-hand side. And these are the various offices that are affected through the Energy Independence and Security Act. Now, one of the very interesting things is they actually established a research office. ARPA is the Advanced Research Projects Agency for Energy, ARPA-E. And these are the folks that are actually doing all of the science and technical efforts in terms of developing technologies. Here's the answer to your question. So, yes, you want somebody heavy to carry the ball. You want to fortify it. You want in order to score the touchdown. The performance objectives, DOE came out. They got after the law was signed, they got about 140 of us together in a very large room, and they said, okay, let's determine how we measure progress toward those objectives. And you'll notice down here at the very end, operate resiliently against physical and cyber attack and natural disasters. So as we're going through these design objectives with those previous ideas in mind, this is how the DOE is going to score the success of the smart grid through these various performance objectives. The whole idea of enabling participation by consumers, so that we can send signals down to the consumer, and the appliances and the consumer themselves can respond properly in their home. Now, we've got thermostats over on the wall here tonight, and one of the things that they're actually doing is the whole idea of green, yellow, and red lighting on those thermostats. We actually have manufacturers, we have companies who have visual indicators, so that if the price of electricity is running up, the power company can send a signal down to that thermostat. It'll light the red light, and then the consumer knows that, well, if I want to save a little money, now is the time for me to go over and turn my thermostat down. So the whole idea of being able to provide information in near real time to the customer so that they can actually control aspects of their consumption. The whole idea of accommodating generation and storage options. Again, the idea of enabling renewables. And if you think back to the title of that law, it was the Energy Independence and Security Act. Energy independence, the whole idea of all of the money that we're spending that goes out of this country on a monthly or daily basis in terms of purchasing oil. So by enabling local generation and storage options, then we can accommodate the renewable market. Enable new products, services, and markets. What we've seen very recently is there's an opportunity for software vendors to come into the energy market in terms of energy management systems. one of the systems that actually exists out there is called BACnet. It's the Building Area Control Network. So if you're in a commercial building like this, it's the whole idea where you have a control center where they can switch